We're going to now look at the distribution of the variables of interest. Let's first define F0 to be the average submitted charge, F1 to be the average payment amount, and F2 to be the average allowed amount. It's clear that this data is aggregated and shows us only the expected or average values for charges. For our purpose, we could treat them as the representative of the actual charges. This, however, is not always a good assumption, but we will work with this for illustrative purposes. Now, let's switch to the IPython notebook and look at the distributions of the average values in the data. So here, we have now defined the three variables, F0, F1, and F2. Once we have defined the three variables, we can now plot histograms with these variables. The code block here plots two histograms on the same graph. Let's execute this code. Once the code has run, it will show you a histogram that looks like this. It's a simple histogram with the average charged amount shown in green and the allowed amount shown in blue. We can try to draw the same histograms for the average charged amount and average payment amount. You can do that by running this piece of code here. Once you run that code, you will have a very similar histogram with the average charged amount shown in green again and the average payment amount shown in red. Let's inspect this histogram a little bit further. We had plotted both the green and the red histograms in the range from 0 to 1000. We also had bins of 50 each. What that means is the entire range from 0 to 1000 was divided into 50 different bins. Each bin then contains the range between 0 to 20, 20 to 40, and so on. The y-axis shows us the number of times a data value was in that given range. This is the simple concept of a histogram. Now you will also notice that the values here are fractional values. This is because both the histograms have been normalized. What this means is that the area under the curve of the histogram adds up to the number 1. To achieve this, we take the original histogram and divide by the area to get the value for each of these columns. Also notice that the shape of the two histograms are quite different. What this means is that the probability of charges between 200 and 1000 are a lot more than the probability of payments made between 200 and 1000. The probability being given by the integral between 200 and 1000 of this curve. In the case here, the integrals are merely the sum of the numbers in each bin. The histogram is in fact an example of a non-parametric statistical model. In the following few videos, we are going to inspect what it means to have non-parametric statistical models in greater detail.